Today we will be discussing how to solve systems of equations by graphing. All right, so first of all, what is a system of equation? System of equation are two or more linear equations that are solved at the same time. So you can have a system that may have one solution, it may have no solutions, or it could have multiple solutions, and we will go through each of those. But first of all, what does it mean for a point to be a solution to a system of equations? So let's consider these two equations. X plus 2y equals 15, and 2x plus 2y equals 16. So the question is the point 1, 7 a solution to both equations? So the first thing we are going to do is to substitute this point into both of these equations. So the x coordinate goes to the x and the y coordinate goes to the y. So if I put in 1, 7, I'm going to substitute the 1 here and then the 7 here. So I get 1 plus 2 times 7 equals 15. And I'm trying to figure out if that's true. I'm putting a question mark there. So we're going to use PEMDAS. So we do the multiplication first. So I have 1 plus 14. Does that equal 15? Yes. So it is a solution to this equation. So now we are going to consider this equation. So I will substitute in the x is 1. So 2 times 1 plus 2 times 7. Does that equal 16? So let's multiply first. 2 plus 14. Does that equal 16? Yes. So therefore, since it works, we'll just use that word works, creates a true statement, a true equation, then we can say that this point 1, 7 is a solution to the system. So remember, it is multiple linear equations solved at once. Now, let's use graphing to try to help us solve these equations. Let's do the same equations as we did, and we are going to graph them both on a coordinate plane. Now, I've been kind of lenient lately about using a straight edge, but we need to use a straight edge for graphing. Otherwise, we are just going to get all confused. So let's look at the first one. X plus 2y equals 15. Now we have to get this into slope-intercept form. So that means we need to isolate our y. So we're going to keep this by itself. So I'm going to subtract x from both sides. And then I have to get the y by itself here. So I'm dividing everything by 2. So I have y equals negative 1/2 plus 15 halves. 15 halves. We know that 15 halves is the same as 7 1/2. Okay, so we are going to graph this equation. So my y-intercept is at 7 1/2, which is right here. And now my slope is negative 1/2. That means I'm going to go down 1 over 2. I know that all you need is 2 points. I like to put just a few more just so that I get that feel. Now I take that straight edge and I am going to graph that line. So let's discuss just for a moment, what does that line really mean? That means, remember, a line is a set of points, an infinite set of points that go in both directions. That means any point on that line is a solution to the equation that I just graphed. I can pick any point, plug the coordinates in, and it will be a true statement. That's the whole point of graphing a line. Now what I'm going to do is take my second equation, 2x plus 2y equals 16. And I am going to graph it on the same coordinate plane. So I need to isolate my y. So I'm going to subtract 2x from both sides. I'm left with 2y on the left, negative 2x plus 16 on the right. I'm going to further isolate that y by dividing everything by 2. I'm left with y equals negative 1x plus 8. So we know that when we just see negative 1, whenever we have a whole number right here, we can put it over 1, so we have a rise over run. So our y-intercept is at 8, and then we are going to go down 1 over 1, down 1 over 1, down 1 over 1. And when we create our line, we see that these two lines cross at one point. And if you look carefully, now my graphing is not 100% accurate. Nobody's ever will be when you're drawing these things. But you can see that there is a point where the two lines intersect. That one point is the solution to both of these equations. Remember, the first line that we drew were the solutions to the first equation. The second line that we drew are all the solutions to the second equation. The point at which they cross, that is where they are equal. That point is equal to both equations that make them both true. Okay, let's do two more examples. I have these two systems, y equals negative 4x plus 2 and y equals negative 4x plus 1. Let's graph them both on the same coordinate plane. Now we can see that both of these are in slope-intercept form already. We don't have to do anything to them. You're welcome. All right, so the first one, we have a y-intercept of 2 and a slope of negative 4. So we put that over a 1, so we go down 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4, and over 1. So I will now draw that line. So just as a reminder, that line that we just drew on the coordinate plane, that is the set of all points that solve this first equation. Okay, now I will have the next one. So I have a y-intercept of negative 1 and then a slope of negative 4. So that's negative 4 over 1. So I go down 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4, and over 1. So when I graph that line, now my graphing isn't exact, but you can see that those points never intersect. So what this means is that there is no point that is on both lines. They're parallel. And so we will figure out or determine at some point in the future, we'll determine why that is. But this one has no solutions. Let's do one more. So x plus y equals 3. Let's first solve this, put that into slope-intercept form. We are going to subtract x from both sides because we're going to isolate that y. So y equals negative x plus 3. We can now graph that. Remember, if you have negative x, this is really the same as negative 1x. And we can put that over 1. So I have a y-intercept of 3 and then down 1 over 1. So here is the first equation. All right, so now let's look at the second equation. 2x plus 2y equals 6. Let's isolate our y. So we are going to subtract 2x from both sides. 2y equals negative 2x plus 6. Now we're going to divide everything by 2. So we get y equals negative 1x plus 3. So 3 is our y-intercept. And we go down 1 over 1, down 1 over 1, down 1. Oh, look at that. That is the same line. So when this happens, if when you graph both of these equations, it turns out to be the same line, this means it has infinite solutions. Any point on this line will solve both of these equations. So this last equation, we have multiple solutions. This one has no solutions, and this one has one solution. Now we'll go practice.